Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on formulas for combinations and permutations. And we're picking up where we left off in the previous two parts. And this is topic 3, why do these formulas work? Here again is the general formula for a permutation. NPR equals n factorial over n minus r factorial. And again, this is the general formula for a permutation. Why does this formula work? So if I have 5 letters, such as A, B, C, D, and E, and I want to list the permutations or arrangements of those 5 letters if I take or pick 3 of them. That's my goal, is to do so. Because if we're doing a permutation, remember that no repeats are allowed and order is important. And the notation for that is 5p3. And here is a list of all of the different permutations or arrangements. There are 10 by 6 or 60 ways or 60 different arrangements of 3 of the 5 letters. This would be too time-consuming to make a list each time, so an alternate way would be needed to think about this. And here is an alternate way. We can think about it as the number of ways to select the first letter times the number of ways to select the second letter times the number of ways to select the third. And how many ways are there to select the first letter? There would be 5. How many ways are there to select the second letter? 4. How many ways are left then to select the third letter? Remember, each time we select it, we can't repeat a letter. That's why it decreases and gives us 3 for that last one. And every time, order is important, so each different order would be considered different and would count. So that gives us 5 times 4 times 3. 5 times 4 times 3 is the beginning of 5 factorial without the last 2 times 1. So if we thought of it with the 2 times 1, we would need to cancel out the 2 times 1 so that it would be equivalent to what we had. So that way we could write it with factorials, and that then gives us 5 factorial over 2 factorial. Now, how does this relate to what our directions were of a permutation of taking 5 from the 5 letters, taking 3 of the letters and choosing 3 of the letters? Well, we can get the 2 by subtracting the 5 minus 3, and guess what? That relates back to our general formula. Keeping that there in mind at the bottom, remember our general formula is NPR equals n factorial over n minus r factorial. N being the total number we're selecting from, and n minus r factorial on the bottom being the difference between the total and the number we're selecting. Now let's look at our combination formula, and in general that formula is NCR equals n factorial over n minus r factorial, r factorial. Why does this formula work? Again, we're going to start with the same 5 letters and we're going to choose 3 from that as a combination. Because we have a combination, no repeats are allowed and order is not important. Notice our list from before. And in this case, order is important, so some of these are repeats or different arrangements of the same letters. That first column is the set of letters, and the first column is the set of letters, and along each row is just the rearrangement of those letters. So we want to just ignore those. So when order is important, we have to consider all of those different arrangements and count them. When order is not important, we do not count the rearrangement as a different group. So we have only 10 unique sets of letters where no repeats are allowed and order is not important. How can we arrive at that answer without the list of possibilities? We have that total of 60 divided by 6, the number of different arrangements of the 3 letters. 5C3 is the number of permutations divided by the number of arrangements of 3 things. Notice that the number in each row is the number of arrangements of 3. And if we have 3 things, and how many ways there are to arrange that would be the number of ways to pick the first item, which would be 3, times the number of ways to pick the second item, which would be 2, times the number of ways to pick the last item, which would be 1. 3 times 2 times 1 would be 6. Or in this case, you can see the illustration that it's just 6 across. So that would be 6, so we have 60 divided by 6. So, back to that. So the 60 is the same as the number of permutations, the total that we had in our permutations. So that gives us the number of permutations that we had for 5P3 divided by the number of arrangements of 3 things. So that's 5P3 divided by 3 times 2 times 1. And if we remember what our formula for 5P3 is, that was 5 times 4 times 3 times 2 times 1 over 2 times 1, which gives us, and there you see it highlighted, that's your permutations. And that gives us 5 factorial over 5 minus 3 factorial divided by 3 factorial, because 3 times 2 times 1 is the 3 factorial. And this follows the general formula, because in general, NCR equals n factorial over n minus r factorial r factorial. Thank you for watching this video and on the formulas for permutations and combinations. If you need more help and are a Walters State student, please come by the Math Lab in MBSS 222. Thank you.